All right, let's solve some systems of equations. Well, let's see what happens here. Jacob and Paul are selling pies for a school fundraiser. Customers can buy blueberry pies, and blackberry pies. Jacob sold 8 blueberry pies and 12 blackberry pies for a total of $300. Paul sold 10 blueberries and 6 blackberry pies for a total of $240. Find the cost of each one blueberry pie and one blackberry pie. So there are two variables here. And I'm going to let x be the blueberry. So it's the blueberry pie cost I'm looking for. And I'm also looking for the blackberry pie cost. That is what I need to answer in order to be done with this problem. There's a lot of information out there. So what I'm going to do is try to write an equation for Jacob. Jacob, he sold 8 blueberry pies. So if I knew the cost, I would take 8 times the cost, but I don't know the cost. But I'm calling that x. The blueberry pie cost is x. So if I take 8 times the cost, that's how much money he sold worth of blueberry pies. And he sold 12 blackberry pies. So if I took 12 times the cost of the blackberry pies, that'd tell me how much he sold value-wise of blackberry pies. But I don't know the blackberry pie cost, but y represents that. So I'll take 12, the number of pies of blackberry variety he sold, times the cost, y, of the blackberry pies. Now I add up the two amounts that he sold, the $2 amounts. That adds up to $300. I'm going to do a similar thing with, who is it, Paul. Paul sold 10 blueberry pies. So I'm going to take 10 times the cost of a blueberry pie, which is x. And he also sold 6 blackberry pies, so that'd be 6 times the cost of a blackberry pie, y. Now he earned a total of $240. So when I put all this information together, this is all the information I have, it creates a system of equations. 2 equations with 2 variables. And those 2 variables are both x and y, both the blueberry cost and the blackberry pie cost. So let's see here. We need to create opposites, right? Now, 8 doesn't multiply into 10, so I could create, I don't know, like 40x and negative 40x. That'd be the least common multiple here. But I realize that if I multiply the 6 by negative 2, I'll get a negative 12y. But then I need to multiply the entire bottom equation by negative 2. I just need to bring the top equation over. 8x, positive 12y, positive 300. So now since we have opposite y's or opposite x's, in this case it's opposite y's, remember we can create opposite x's as well. However, I can cancel out one variable. When I add here, the y's do get eliminated. So I get negative 12x equals negative 240. Now if you're nervous that the dollar amount is negative right now, hold on. If our final answer were pies cost a negative dollar value, that would be concerning. But let's solve for x, the cost of a blueberry pie. Now I need to divide by negative 12, and remember a negative divided by a negative is a positive, so we get positive 20 here. So I know that x is 20, and x represents the cost of a blueberry pie. So I know that a blueberry pie, or one blueberry pie, a blueberry pie costs $20. Well, wait a minute. Now, if I know the cost of a blueberry pie, couldn't I figure out the cost of a blackberry pie? I'm going to use the bottom equation because the bottom equation has smaller numbers. So I'm going to take, Paul sold 10 blueberry pies, and he made $20 per blueberry pie, or it cost $20. So that means he sold $200 worth of blueberry pies. So that means, I don't know. That means he only sold $40 worth of blackberry pies. And so then I'm getting a decimal. I don't know. Maybe that can happen. Divided by 6, divided by 6. we get y equals $6.67, which I don't feel good about because I don't think that was the right answer. Decimals do happen. It could be. 160. So I'm just checking my work. I'm plugging 20 in there. I get 160. And if I'll even call it $7, that gives me 84. That doesn't add up to 300. So I made a mistake somewhere. Let's see if I can find it quickly. Oh, shoot. I did the math wrong. Obviously. Yeah. That multiplies to negative 480. Which makes this be negative 180. Which makes this be $15. So then he didn't sell $200 worth of blueberry pie. He sold $150 worth. So let's subtract that away, which means he sold $90. That raises the amount of the blackberry pies that he sold, and that makes it $15 per blackberry pie. So blueberry pie costs $15 and a blackberry pie costs $15. Silly, we should have realized that maybe they cost the same amount. Just kidding. You gotta calculate it. You can't assume they would be the same amount. So there we are. Sorry about goofing up on that one, folks. My bad. And that is the thing. If I wouldn't have caught that mistake, and if I had y equals $6.67, I realize it's not right. Hopefully I can catch it. But if I don't, keep your work there. Let me see what you thought through. If Mr. P were to grade himself on that without catching the mistake, it'd be like an A-, but it's still good. I had a lot of good stuff there. I won't goof up on the next one. I'm sorry. All right. Matt and Shauna are selling cookie dough for a fundraiser. Makes me hungry. Customers can buy packages of white chocolate chip cookie dough or gingerbread cookie dough. Matt sold 13 white chocolate chip and 5 gingerbread for a total of $140. Shauna sold 1 package of white chocolate chip and 12 packages of gingerbread for a total of $127. Find the cost of 1 package of white chocolate chip cookie dough. Whoa. And find the cost of 1 gingerbread cookie dough. So I'm going to let X be white chocolate chip. White chocolate chip. Now it's the cost. That's what we don't know. We know how many we sold. And Y is the cost of the gingerbread dough. Cost dough. All right. So let's go through. Let's try to build an equation. So Matt sold 13 of the white chocolate chips. So that'd be 13 times X to give me the cost or the total amount that he sold worth of white chocolate chip. He also sold 5 gingerbread. So I'd take 5 times the cost of the gingerbread Y. And that would tell me the total dollar amount that he sold, which they tell us is $141. So that equals $141. Shauna, on the other hand, sold 1 of the white chocolate chip. So it'd be 1 times the cost of a chocolate chip. She sold 12 gingerbread. So I'd take 12 times the cost of the gingerbread Y. And when I add my 2 costs together, she got $127. All right. These are some big numbers. I need to run and grab a calculator. So I could figure out the least common multiple of the y's. That'd be 60. So I can multiply the top by 12 and the bottom by -5. And that'd be fine. Or since I'm multiplying a bunch of times then with a pretty big number, I'm just going to multiply the bottom by -13 to give me a -13x, which is opposite this positive 13x. I'm going to need a calculator on that. So I'm not changing the top equation. That's easy. The bottom equation gives me a -13x And then here that would be negative 156y. And right there I need a calculator. Ooh, that's going to be a big number and I don't have enough space for it. $127 times negative 13 equals negative 1,651. It's a negative. All right, so now I'll add that together. I still have that number in my calculator, which is handy. So then when I add these together, I get negative 151y equals, I'm going to take that negative 1,651 and add a positive 141 to it, which gives me negative 1,510. Now I solve for y by dividing by negative 151. Divide by negative 151. We get y equals 10. So the cost of a gingerbread cookie gingerbread dough is $10. So now I go back to one of the two original equations and substitute that in. I'm going to use the bottom equation. Numbers are a hair smaller. Not that that matters. You have a calculator. So since she sold 12 gingerbreads and they're worth $10 each, that means she sold $120 worth of gingerbread dough, which I'm going to subtract off. So that leaves $7 for whatever she sold in white chocolate chip, which she only sold one white chocolate chip. I don't really need the 1 in front of that. 1x is the same as x. So x equals 7. X represents the cost of a white chocolate chip. So a white chocolate chip package is $7, and a gingerbread package is $10. Nice. All right, number 3 I think was done in the other video.